We spend so much time building these digital fortresses to protect our data. But what if I told you there's this critical moment, a hidden vulnerability, where most of that data is just left completely exposed? Today, we're going to dig into that exact gap and the amazing technology designed to seal it up for good.
So, you've done everything right. Your data is encrypted when it's just sitting on a hard drive. We call that at rest. And it's encrypted when it's flying across the internet. That's in transit. So we're all good, right? Job done? Well, that's the big question, because there's one more state that we really need to talk about.
And that's it. That's the moment. It's when your application actually needs to process the data. When it's loaded into memory to be analyzed or changed. At that point, it has to be decrypted. Think about it like this. You've locked every single door and window to your office building, but you've left the most sensitive documents spread out on a desk in a workroom that's completely unlocked. This in-use phase, that's the security gap we're laser-focused on today.
So the big question is, how do you finally lock that workroom door, even while someone is inside working with the documents? Well, this brings us to the solution, a really powerful approach called confidential computing.
And the whole game, the entire point, is in those last 4 words, while they are in use. That's what changes everything. This isn't just some other layer of encryption for your hard drive or your network traffic. No, confidential computing is all about creating a protected, totally isolated environment where data can be safely decrypted and processed, completely shielded from everything else running on the system.
In this quote just hits the nail on the head. It's not enough to just create a secure space, you have to prove it's secure. Before any sensitive keys or secrets get handed over to an application, that app has to prove, without a doubt, that it's running inside a legitimate, tamper-proof environment. And don't worry, we'll unpack what attestation and TEE mean in just a sec.
All right, so that's the what and the why. But how does this actually work? How can you possibly create a secure vault inside a computer that's already running a complex operating system and who knows how many other applications?
Okay, so the magic all happens inside this thing called a Trusted Execution Environment, or TEE for short. The absolute best way to think about this is like a hardware-based safe room that's built directly into the computer's processor. It's a completely isolated space where your code and your data are protected. And nothing can see inside. Not the cloud provider, not the machine's administrator, not even the host operating system. It's a true black box.
This TE creates a really fundamental shift in how we approach security. For decades, we've been focused on verifying the identity of the user, but in this new model, we're focused on verifying the integrity of the environment itself.
Let's really look at this difference, because it's huge. On the left, traditional security asks, are you who you say you are? It's all about user passwords, multi-factor authentication, that kind of thing. But on the right, confidential computing asks a totally different question. Is your environment trustworthy? And this is revolutionary. It changes the basis of trust from something that can be stolen, like a password, to something that can be cryptographically proven, the integrity of the hardware itself. You literally don't have to trust the cloud provider or the admin anymore.
So how do you answer that big question about whether the environment is trustworthy? Well, you do it with this process right here, attestation. This is the cryptographic proof we were talking about. It's a mechanism where the TEE can prove to some outside service, like a key vault, that, hey, I'm a genuine hardware-secured environment, and the code running inside me is exactly the code you expect. It's basically the secure vault showing a digital ID card that's impossible to fake.
So here's how it all clicks together in a real-world scenario. Step 1. Your application, running safely inside the TEE, says, hey, I need a secret key. Step 2, the TEE then proves its identity and its integrity to the key service using that attestation process. And finally, step 3, and this is the crucial part, only if that proof checks out, the key is released directly into the protected TEE, never once being exposed to the outside system.
Okay, this all sounds great in theory, right? But is this real? Is anyone actually using this stuff? Absolutely. This isn't just some concept on a whiteboard. It's a foundational technology that's already powering major services in the real world, especially within Microsoft Azure.
Yeah, this technology is the backbone for a whole bunch of Azure services. It's behind confidential virtual machines, which are basically these TEEs at a massive scale. It's used for confidential nodes if you're running container apps in AKS. And it's even used for ultra-secure key management with Azure Key Vault's managed HSM, which is essentially your own dedicated hardware-based vault for your crypto keys in the cloud.
Let's make this super concrete, okay? Picture this. You have some highly sensitive data sitting in Azure Blob Storage.
all nicely encrypted. Your application running inside a confidential VM can pull that encrypted data directly into its secure TE, use a key it gets through that secure release process to decrypt it, run all sorts of complex calculations on it, and then re-encrypt the results before anything goes back out. The raw, unencrypted data never, ever leaves the protection of that hardware vault. It's incredible.
So we'll leave you with this thought. We've pretty much mastered protecting data when it's sitting still and when it's on the move. But as we've seen today, that's only 2/3 of the story. Confidential computing finally locks down that last, most critical phase. And that leaves a pretty big question for all of us to think about. If we're not protecting our data at its most vulnerable moment, are we really protecting it at all?